Hey guys, welcome to my channel. Have you ever imagined that a ship could sail over mountains? This isn't just something out of a movie or a dream. It's a reality. You can turn your fantasies into reality. And to do so, you must come to China. In the modern world, all of this is only possible thanks to dams and hydropower systems. Approximately 1/3 of the world's installed hydropower capacity comes from China. This is not surprising, as there are countless hydropower stations in the country. It's one of the largest hydropower stations on our planet, with an installed capacity reaching 1 million kilowatts. Its scale is enormous, and its annual power generation is truly remarkable. Although its installed capacity is lower than that of the Three Gorges Dam, it still ranks as the second largest hydropower station in the world. In fact, the world's top 5 hydropower stations are all Chinese projects. In today's video, you will learn how Chinese engineers accomplished this feat. They used shiplifts to turn fiction into reality. This is the Gupitan hydropower station. Here, the dam stands 232.5 meters tall, and the total lift height of the shiplift reaches 199 meters. This lift is equivalent to 66 stories. Ships are raised in 3 vertical stages to bypass the dam. They travel directly from the lower to the upper reaches of the Wujiang River, making it one of the world's largest shiplifts. So, how does this shiplift actually operate? First, a 500-ton vessel enters a gigantic ship-carrying chamber. The chamber measures 40 meters in length and 12 meters in width, flooded with water to create a moving waterway. It is towed by 256 steel cables and is raised and lowered vertically via a gear rack climbing system. Each stage of the operation takes about 30 minutes. The ship must ascend through 3 levels of the shiplift. This takes a total of approximately 2.5 hours, reducing the journey by 4 days compared to traditional winding mountain routes. Employing a world-first gear rack plus nut column safety system, it can withstand an 8-level earthquake. In extreme wind and waves, the lift's precision is maintained within plus or minus 10 millimeters. This ensures that 1,000-ton class vessels can traverse the mountains smoothly. This project has restored full navigation along the Wujiang River, opening up the Golden Waterway. It connects Guizhou to the Yangtze River, increasing annual freight capacity to 5 million tons. Boosting the development of the Central Guizhou Economic Zone, the International Shipping Association has described it. They have even described it as redefining the possibilities of inland navigation. Now, observe a ship sailing along a canal that, upon approaching a tall building, enters its interior. Inside this structure, a lifting cable hangs, flanked by 2 rows of drums and gearboxes on either side. To residents of a typical multi-story building, such an elevator might seem both fascinating and unusual. The shiplift is both incredible and sluggish due to its enormous internal footprint. Designers claim this shiplift can raise and lower a 500-ton vessel in about 10 minutes. In other words, a standard passenger ship can easily depart from its original position quickly. The massive lift boasts a maximum load capacity of 18,800 tons. Any waterborne vehicle will be lifted to an astonishing height of 72 meters. This height can vary depending on the downstream water level, reaching up to 200 meters. Some consider the shiplift system at the Gupitan Dam an incredible feat of engineering. Of course, such praise is open to debate, as shiplifts have been used worldwide for years. However, you will notice that this system does not consist of a single elevator. In fact, it actually comprises 3 elevators working in concert. Its operating principle is straightforward. The ship enters, waits, and is then raised as a whole. Through the Gupitan Dam's lift system, the water surface of the shipping channel is elevated to 199 meters. This feat is simply unbelievable, raising ships to heights that parallel skyscrapers. To put this in perspective, the height of a ship lifted is like that of a 66-story building. If you were near the Great Pyramid of Giza, its height is 139 meters. Meanwhile, the Statue of Liberty stands only 93 meters tall. These comparisons truly showcase the ingenuity of Chinese engineers. Achieving a lift height of 199 meters is almost unimaginable. Under normal circumstances, a river with such a dramatic elevation drop would be non-navigable. Yet, through advanced engineering techniques, the Chinese have achieved this astonishing feat. This achievement has earned them the well-deserved nickname Infrastructure Maniac. Moving on, after a ship passes through 2 elevators, it must then be lowered. To reach the water behind the dam, the system includes an additional elevator. This elevator has a maximum lowering height of up to 47 meters. Again, the actual height depends on the water level. In terms of throughput, this system might appear rather rudimentary. Although the ship is raised relatively quickly, it accommodates only 1 vessel at a time. This means the elevator system's capacity is not very high. It might even lead to long queues waiting for the elevator. While this arrangement is not perfect, the design engineers have expedited transportation. The system, comprising 3 elevators and a water conduit, simplifies elevation changes. This undoubtedly represents yet another astonishing achievement of Chinese engineering. There remains a certain distance. Between the elevators, there are challenges to navigate, but they present no significant obstacle. Traditionally, locks transfer vessels between different elevations without crossing mountains. However, here, vessels must navigate among rugged mountains. Initially, there was no river beneath the elevator system at all. In addition to constructing the 3 elevators, another challenge was laying a passage between them. Ultimately, the main passage between the 2 elevators and the mountain is an open water conduit. This does not mean building such a passage is uncommon. Ancient engineers achieved similar feats without modern technology. However, integrating the waterway system with rugged mountain terrain increased the challenge significantly. Nonetheless, Chinese engineers successfully overcame these difficulties. They completed the second mountain crossing route. You need not wonder how China managed this feat. The country has considerable experience in tunnel construction. They use giant tunnel boring machines to excavate tunnels efficiently. As a result, a mountain route spanning 2.3 kilometers was born. The entire project cost a staggering $7.775 billion. It is precisely because of this shiplift system that vessels can traverse perilous terrain. If a more traditional lock system were used, ships would face far more difficulties. You may have realized that the water conduit and elevator system were built for the Gupatan Dam. This ship lift system is fundamental to the dam's supporting facilities. In summary, the Gupatan Dam and its hydropower station aren't particularly remarkable on their own. The unique aspect is their highly advantageous navigation system. This system allows ships to effortlessly fly over mountain ranges. This raises another question: why such an enormous investment was necessary? The project consumed vast amounts of effort, time, and capital, especially when the project itself doesn't seem all that grand. First, let's examine the location of the dam and its navigation system. For ships, this area is narrow and environmentally harsh. Using a traditional lock system was simply not feasible. After the Gupatan Dam's completion, engineers undertook significant work overall. Building any dam creates a barrier in the river, causing water levels to rise. In some places, this difference might not be very noticeable. However, in the case of the Gupatan hydropower station, the difference is immense. In this context, the hydropower station became essential. Although the project required enormous labor and costs to develop new energy in the region and establish a transport network, Guizhou built the Gupatan hydropower station. The shiplift system has an impressive annual cargo capacity of 2.928 billion tons. Some might argue that using semi-trailers or rail cars for transport is feasible, but these methods are less efficient. For instance, a standard truck can carry about 23 tons, while the Gupatan shiplift can hoist a 500-ton ship. This is not even the limit. A single barge can replace dozens of trucks. Considering the road construction in Guizhou's mountainous areas, it's nearly impossible to build wide highways. These highways would need to accommodate large numbers of trucks and tourist vehicles. Allowing trucks to navigate narrow mountain roads poses significant risks. Since water transport exists, barges and cargo ships are more fuel efficient. While rail transport is slightly better, it faces challenges like laying tracks and lower efficiency. Despite these challenges, the region achieved the optimal solution through massive investment. As a result, we can witness a spectacular sight and understand the reality of sailing ships through mountains. A ship lift capable of hoisting 10,000 tons is an incredible feat of engineering. The completion of this project has left a profound impression on viewers worldwide. Many remarked that the ship lift alone is jaw-dropping. This navigation channel built on the towering bridge of the hydropower station is world-class. The design and construction quality are simply mind-blowing, and the water tunnel cutting through the mountains is pure genius. China achieves such incredible infrastructure for less than half the cost of a destroyer, all while maintaining navigation on a major river. What a bargain! Others added that projects like this feel routine for China, yet they are engineering marvels. If this were in the US, it would take roughly 50 years to plan and another 50 to build. While some comments may be exaggerated, they reflect the staggering capabilities of modern engineering. Let's take a look at the ship lift at China's Three Gorges Dam. This lift system can hoist ships weighing up to 3,000 tons, completing a round trip in just 40 minutes. These numbers are staggering on their own. As the saying goes, with great power comes great size. The lift's chamber measures 122 meters in length and 18.3 meters in width. It holds a volume of water equivalent to 4 Olympic-sized swimming pools. Its colossal scale allows it to accommodate nearly any vessel at maximum capacity. Imagine lifting a ship of such immense weight to a height of 113 meters above the ground. It's an almost unimaginable engineering challenge that has been successfully met. Chinese engineers have invested significant effort into safety measures. They have installed 4 sets of symmetrically arranged drive mechanisms. These mechanisms firmly reinforce the 4 corners of the ship's cabin. This setup effectively eliminates adverse effects from tilting or swaying. This greatly reduces the risk of capsizing. Designers ensured that even in emergencies, the system remains safe during seismic activity. The lift cabin is equipped with cushioning devices that absorb vibrations and shocks. A construction expert involved in the project highlights the seismic protection system. This system dissipates seismic forces across multiple support pillars. This design prevents chamber collapse and catastrophic failures. Since the commissioning of the multi-stage lock system at the Three Gorges Dam, its benefits have started to emerge. This marks a 10.32% year-on-year increase, setting a new historical record for the Three Gorges locks. Before the ship lift became operational, vessels had to traverse the dam. This process was enabled by another engineering marvel, the 5-stage lock system. Installed adjacent to the dam are 2 parallel lock complexes. Each consists of 5 chambers, with a total transit time of approximately 4 hours. This time gap of 40 minutes versus 4 hours is precisely why China is prioritizing the construction of a new lock system. Such delays could severely impact individual businesses and the broader Chinese economy. The Yangtze River serves as a critical maritime artery. But just how impactful are these locks? Even with a 4-hour transit per vessel, the dam's annual cargo volume hit 180 million tons in 2024. This figure continues to grow alongside China's economic expansion. Notably, initial projections estimated a maximum annual capacity of just 100 million tons. This number has been clearly underestimated. With each megaproject built, China continues to overcome world-class engineering challenges. Through innovative techniques and advanced construction methods, China has earned the moniker infrastructure maniac. Moreover, China has undertaken major projects in numerous other countries, each emblematic of its development drive. Behind China's global leadership in infrastructure lies not only a leap in technology, but also the support of a mighty nation. For over a century, from the devastation at the founding of the People's Republic of China, it has been the struggles of generations of engineers. These efforts have painted the picture of today's prosperous China, and yet this is not the end for China. In the future, the infrastructure maniac will continue to help more developing countries modernize. They will create new opportunities. Development helps us build a better, more livable world for everyone. Each bridge, every road, and every project connects cities and countrysides, the present and the future, China and the world. Chinese infrastructure has reshaped the face of China. It also exemplifies the strength, spirit, and speed of the nation. The infrastructure maniac will never stop. What miracles do you think Chinese infrastructure will create in the next decade? Please share your thoughts in the comments, and don't forget to subscribe. See you in the next video.